Good morning, everyone. In the last video, that is the continuation of last video, we can say. In the last video, we saw the different type of bonds and their respective types, like covalent bond, ionic bond, hydrogen bonding, and their types. Also, we saw the continuation part of that bond. That means sigma and pi bonds. And one point, what I said you in the last class is, in the last concept is about bonds. There will be a presence of a single or double or triple bond between any two atoms. Or else, for this we can take O2 as a good example. For this we can take N2 as a good example for triple bond. Right? So this is in case of organic chemistry, and one we can normally see in case of different types of atoms. Or else example we can say. So now we already know that if there is a single bond present in between any two atoms, then there will be a involvement of two electrons. If double bond is present, definitely four electrons. If triple bond is present, then one we can say that there are six electrons involved in these three bond formation. One point, but we don't know whether the bond is which bond is sigma and which bond we should call as a pi bond, right? In today's video or in today's class, what we going to see is for to which bond we should call as sigma, or to which bond we should call a pi bond. So that is the concept now. Before going to this concept, first, we will see the some rules. That means how to identify whether the bond is sigma bond or a pi bond present in between any two atoms. So now, see, there are four rules, and these rules are very easy rules. So first one we will see now. So in the first rule, if single bond is present, if single bond is present, if single bond is present between the atoms, two atoms you can say, between two atoms, or between two atoms we can say now, between two atoms, then that bond will be always what? Sigma bond. See, these rules are very important to understand which bond is present in between any two atoms or in between in the molecule, we can say. So now, if very clearly we can observe over here, if in between any two atoms like this, we will take one example, and you can say this as a alkane example. So like this, if these are the two atoms, the carbon and carbon, or else you can take any example like HCl, H and sorry, H and H, like HCl. So these are all are the single bonds. So in such cases, in single bond, if single bond is present between any two atoms, then that bond will be always a sigma bond. To that bond, what we need to call, we should say the single bond is always a sigma bond, right? So like this, that means the first rule says if single bond is present, then that will be always a sigma bond. So this is about the first rule, and which is very easy. Again, if double bond is present between, if double bond is present between atoms, like two atoms we can say, between atoms, then one will be sigma bond, and other will be pi bond. Very important. Very important. Now, if double bonds are present in between any two atoms, again the same concept. If the double bonds are present, we'll take examples. Some examples. Alkene, you can say CH2, CH2, right? Hydrocarbon. So now here we clearly see that there is a presence of two bonds. That means if in such cases always one will be sigma bond, either it may be upper bond or lower bond. We can say there is no rule for that upper bond only should call sigma or lower bond should call pi. No, not like that. You can call one, you can take any one bond in between these two, right? One should be pi, then automatically other will become pi. But if one will be sigma, then automatically other will become pi bond, right? So likewise, if double bonds are present, then definitely what we can say one will be pi bond and other one will be the sigma bonds. Now, if triple bond is present, if triple bond is present between atoms, if triple bonds are present between atoms, then now, which is very important now, then two bonds are pi bonds, and one bond will be sigma. Right? So if triple bond is present, okay, let us have an example. C triple bond C, right? Alkyne. One more hydrocarbon, that is alkyne, or else you can say N2. Is the best example. So now, in such cases, that means if triple bond is present between two atoms, then two bonds among these three, two bonds are always what? Pi bonds. Among these three, very important, among these three bonds, two bonds are pi bonds and remaining one bond will be what? Sigma bond. Very important. Now, here you can call this as a pi or else this as a pi and this as a sigma, or it might be a sigma or rest 2 will be pi, like this you can call. That means, but what we need to remember, whenever there is a presence of triple bond in between any two atoms, then definitely there we see two pi bonds and one sigma bond. And finally, this is about the third rule. Coming to last rule, that is fourth rule. This rule is particularly for about those compounds which is present in the organic compounds or else organic compounds. That means in this rule, always in between carbon and hydrogen there will be a sigma bond. Whenever we see a bond between carbon and hydrogen, there will be always a sigma bond. This is about fourth rule. In between carbon and hydrogen, that means you say this as a hydrogen, this is also as a hydrogen, or this as a hydrogen. Always in between, if there is a bond between carbon and hydrogen, then that bond will be always what? Sigma bond. This is about fourth rule. I repeat, first rule is about single bond. That means if a single bond is present between any two atoms, then definitely that bond will be always a sigma bond. Second rule of about double bonds. If double bond is present, then one will be sigma and other one will be pi bond. If triple bonds are present in between two atoms, then definitely in such cases two bonds are pi bond and one bond will be always sigma bond. And finally, the fourth rule is if in between carbon and hydrogen, if there is a formation of bond, then definitely that bond will be always a sigma bond. So these are the four rules. Now let me explain or let me define what is sigma bond. So sigma bond first of all, and these sigma bonds are denoted by sigma, right? Now these sigma bond is nothing but whenever see overlapping takes place. That means what we said, if one molecule reacts with other molecule means in between those two molecule or in between those two atoms definitely overlapping takes place. That's why they form a bond. If head to head overlapping like this, if I say consider this as a one atom and this as a other atom, if I bring them close, definitely what happens? Electrostatic force of attraction develops, and definitely they attract each other. When the attraction starts, definitely they overlap on one another. That means whenever the head-to-head overlapping takes place, then that leads to the formation of what? A bond. That bond is called as sigma bond. Whenever in between two atoms head to head, or else we can say head on overlapping, head on overlapping. If overlapping is like head to head overlapping like this, if you consider the head of one atom and this as head of other atom, that means if head to head overlapping takes place in during the class, we come to know what is head to head overlapping. But for now, to understand the sake of understanding the sigma bond, one you can consider head to head overlapping whenever takes place, definitely in between two atoms there will be a formation of sigma bond, right? Such bonds are called as what? Sigma bonds. That means head to head overlapping or head on overlapping, right? So during the sigma bond formation, right, take this as a one example, right? I mean, this is take this as a one atom and one more atom. If we make them overlap, then if they undergo head to head overlapping, then extension of overlapping will be always more in case of sigma bond. Extension means one molecule nearly 50% penetrate into the other molecule, right? One molecule can penetrate or extend till 50% like this, right? Approximately 50%, I mean half of the molecule like this, it will come nearly like this and they overlap. That's why these sigma bonds are very strong bonds, right? Why? Because once the sigma bond is formed between two atoms, it is bit difficult to remove that bond. Why? Because extension of overlapping is or the penetration is more, right? One molecule is overlapping on other molecule nearly 50% of its area. So that's why due to the extension of area, that bond will be always very strong bond, right? So first point what I said about whenever the head to head overlapping takes place like this, then always the formation of sigma bond takes place, and the sigma bonds are very strong bonds. Why? Because the extension of overlapping is more in case of what? Sigma. So that's why if the extension is more, definitely that bond will be always a strong bond. This is about sigma bond. And now pi bond. second one pi bond, and these are denoted by pi like this. These bonds can be denoted by a pi. So now, whenever, right, whenever the side-wise overlapping, side to side, like this, I will show you. Consider this is a one atom and this is one more atom, like this, right? Whenever side-wise overlapping takes place during the overlapping sidewise, side to side, like this, side to side. This is the side of one atom and this is the side of another atom. If this type of overlapping takes place, then this will lead to the formation of what? Pi bond. Clear? So head-on overlapping takes place, then those type of bonds are called as sigma bonds. If sidewise or sideways overlapping takes place, then those are called as what? Pi bonds. Whenever sidewise overlapping takes place or side to side overlapping takes place, then definitely the formation of pi bond takes place, but the bond will be very weak. Weak bond formation. But in case of sigma bond, what we saw is the sigma bonds are very strong bonds. Why? Because extension is more. But here clearly you can see there is no extension, as we saw in case of sigma bonds. So that's why sigma bonds are more strong. But here just sides are touching, but the no penetration, right? Like sigma bond. So that's why now what we can do, we can very easily remove these bonds or separate these bonds. But once the sigma bond formed, it is very difficult to remove. That means if we compare both these bonds, the sigma bonds are very strong. Why? Because the extension of overlapping is more. But in case of pi bond, the extension of overlapping is less. So that's why these pi bonds are less stronger as compared to the sigma bonds. So this is all about what sigma and pi bonds. So these sigma and pi bonds will be very important for you people to understand how the overlapping takes place, right? So these are the some basic things again about the bonds. So that's why I took this part as a very important part for the for video class. So therefore, again in this class, what we saw is we saw what are sigma and pi bonds. So sigma bonds are what? That means first of all we saw rules. Those four rules are nothing but what? They explains whether the bond present between two atoms, whether it is a sigma or a pi. If single bond is present, definitely a sigma bond. If double bond is present, one will be sigma and other one will be pi bond. And if triple bonds are present in between two atoms, then definitely two will be pi bonds and one will be sigma bond. And in between carbon and hydrogen, if there is a bond, then that will be always a sigma bond, right? That means what we can say is, if there is a single bond present, then that bond will be always a sigma bond. So now, what is the importance? After knowing these presence of sigma and pi bonds, what we come to know? That means, see, this part is very big part. During the theory class, we will come to know, but I took just a bit of it, right? So these sigma bonds, say for example, if its number of sigma bond increases, like you can see in the chain, right? If the number of these are single bond means sigma bond only, and sigma bond denoted by this, right? So now, if the number of sigma bond increases, then what happens? The molecule will become stronger and stronger, right? Why? Because what we said, the sigma bonds are always strong bonds. So that's why these, as the chain increases, catenation increases during the organic part. I will explain what is catenation and all. But now, for the sake of understanding, you just consider this example as a long chain or straight chain compound. If the number of sigma bond increases, then the compound become very stronger, and if we want to remove or break this molecule, we require high amount of energy. See, on the basis of what we are saying, it requires high amount of energy based on the presence of sigma bond. In the same way, if the pi bond is present, then it is very easy to remove, right? If only a single pi bond is present, I mean with like this, then if I consider this as a pi bond, upper bond is a pi bond and this as a sigma bond, then I require less amount of energy to break this bond, but I require large amount of energy to break this sigma bond. Okay? So pi, and this is the difference between pi and sigma bonds. Okay? So this is all about the bonds and all. Now in next session or in next video, I'm going to start organic chemistry, right? And dear students, I would like to say one thing. Remember, organic chemistry is very important chemistry, right? Not only for your first year, but in second year. In the introduction class only, I said nearly the question in the question paper you see 43 marks of questions are from organic chemistry only. So that's why please, during organic chemistry classes, please be attentive and watch all the videos, so that you come to know why. Because the videos are linked. I mean, if you skip one video, then definitely you will skip half of the portion. So that's why now on, from tomorrow's video, I mean next video, definitely I will be dealing with the organic chemistry. And organic chemistry is very basic. In organic chemistry, we will learn nomenclature, from nomenclature to reactions and type of reactions and everything. Again, we will come with these sigma and pi bonds in organic chemistry also separately. So that's why organic chemistry is very important, and you just whatever I explain in the particular class, you just go through the books, so that you will be having more idea about those things, right? Don't depend on these videos. After seeing these videos, the same concept you take from the book and try to read more detail about these concepts, so that what happens, you will be having a good knowledge about that. And definitely, if any doubts comes, if you read briefly in the textbook, definitely the doubt will come. If doubt comes, if we once we clear the doubts, then it will be very easy for you to understand the concepts. So this is all about today's class. But in next class, I will start with the organic chemistry. So that's why the next classes will be very important. And once if you come to know what is organic chemistry and all, then it will be very easy for you to learn whole chemistry. Why? Because the interest will come with organic chemistry only. If you come to know, or if you start doing nomenclating the compounds, then it will be definitely the interest will come towards the chemistry. So that's why I once again request you people, don't miss any video or any class, or don't neglect any concepts. If it will be sometime it will be clear, sometime it will not be clear, I mean concepts. So in such case, you can ask us, right? That freedom we can give for our subject. So that's why don't skip anything. Thank you.